Dark square presents distance between points. Let's say we have the x and the y axis. So this is x and this one's y. And there are 2 points on the xy coordinate plane. The points can be in any of the 4 quadrants. I'm going to assume they are both in the first quadrant. So let's call this point A, and let's say x1 comma y1, and let's call this point B x2 comma y2. So we want to find the distance between A and B, which essentially means we want to find the length of this line segment AB. And to be able to do that, we go ahead and draw a line segment that's parallel to the x-axis and one that's parallel to the y-axis, and the two meet at a point and they form a right angle over there because the x and the y-axis are perpendicular to each other. And let's call this point C. So we have triangle ABC. The triangle ABC is right angled at C. And how about the coordinates of point C? Now if you look at C, the x coordinate of point C is the same as the x coordinate of point B. So this is going to be x2. And in the same way, the y coordinate of point C is the same as the y coordinate of point A, and that is going to be y1. Because ABC is a right triangle, we can go ahead and apply the Pythagorean theorem on this. Pythagorean theorem tells us that in a right triangle, the square of the hypotenuse, so in this case AB square, is going to be equal to the sum of the squares of the other two sides. So AB square is equal to BC square plus AC square. Now what's BC? If you look at BC, the x coordinate being the same, the length of BC is pretty much just the difference between the y coordinates of B and C. So this is y2 and this is y1, and this difference is the same as BC. Therefore that is going to be equal to y2 minus y1 square of that. In the same way, AC is equal to x2 minus x1. So there you go. We have the square of the length of AB, and if you take the square roots on both sides and maybe bring the x's before the y's, that looks better actually. Nothing wrong with this form. AB is equal to the square root of x2 minus x1 whole square plus y2 minus y1 whole square. So we have the length of AB. So given the coordinates of the endpoints of a line segment, we can find its length by using this formula. Let's look at an example. Find the distance between the points A -5 comma -1 and B 1 comma 5. The distance is going to be A to B is square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is what the distance formula is about. So we have a x1, y1. By the way, you can name the points in any order. So if you want to, you can name A as x2 comma y2 and B as x1 comma y1. You'll still end up getting the same answer. But I'm going to just follow the order and name this as x2 comma y2. So I have square root of x2 is 1, so we have 1 minus x1 is -5, square of that plus y2 is 5 minus y1 is -1, square of that. Let's simplify that. Square root of 1 minus -5, so that turns it to 1 plus 5, that's 6 square, plus 5 minus -1 is also 6. 6 square plus 6 square. Therefore, this is going to be square root of, I'm not going to say this is 36 plus 36 and add them. up to get a 72. What I'm going to do is I'm just going to write 2 times 6 square, which is equal to 2 times 6 times 6, and you know how to find the square roots. You pair them up, the factors. You have a pair of 6, take it out outside the square root, so this is going to be 6 square root of 2. Easily done. And that is the length of the line segment AB. Let's try another one. The distance between the points P 2 comma 1/2, so this is 2 comma 1/2, and Q, that's 4 comma Y, is 2 times square root of 2. We need to find the value of Y, the Y coordinate of point Q. So let's straight away apply the distance formula. The distance between 2 points is given as PQ is equal to square root of x2 minus x1. So we're going to assume Q is 2. So 4 minus x1, that's 2, square, plus y2, the y coordinate of Q, that's not given, that's the one we need to find out, minus y1 is 1/2 square. And PQ is given to be equal to 2 times square root of 2. So let's just go ahead and replace PQ with 2 times square root of 2. Our first job is to get rid of the square root, and therefore we are going to square both sides and bring this on this side and this one on the other side, so that we have the variable as per convention on the left hand side of the equal sign. So we have, after squaring both sides and flipping over the right hand sides and the left hand sides of this equation, we have 4 minus 2 whole square plus y minus 1/2 whole square. The square root is gone because we have decided that we are going to square both sides, is equal to, now square of 2 square root of 2 is equal to 2 times square root of 2 times 2 times square root of 2. So pretty much you multiply 2 square root of 2 with itself if you want to square that. And this is going to be equal to 2 times 2 is 4 times square root of 2 times square root of 2 is 2. Therefore all of that is equal to 8. So that in the next step we can write down 4 minus 2 is 2. 2 square plus y minus 1/2 whole square is equal to 8. We know that 2 square is 4, so we can subtract 2 square from both sides, minus 2 square minus 2 square, so that we have y minus 1/2 whole square is equal to, these two cross off, 8 minus 4 is 4, which means y minus 1/2, take the square root on both sides now, is equal to, the square root of 4 can either be a positive 2 or a negative 2. And it's important that we realize that we are going to have two different values of y over here. If y minus 1/2 were to be equal to positive 2, you would go ahead and add 1/2 to get y. Therefore y is equal to 2 and 1/2, 2 plus 1/2, that's 5 seconds if you go this way. Or if you add 1/2 to this, take this 1/2 on the other side, if you take this root, you have y is equal to negative 2 plus 1/2, that's negative 1 and 1/2, that's negative 3 seconds. So this y over here can either be 5 seconds or it can also be negative 3 seconds. Now why are we having two different answers out here? Let's try and understand that. Now if you think about the x and y coordinate plane, I'm just going to draw it over here. So you have x, you have y. If you look at P, that's 2 comma 1/2, so this is the origin of course. P is going to be somewhere over here. This is point P, 2 comma 1/2. And then they said that there's another point Q whose x coordinate is 4. So pretty much we know that Q is going to be somewhere with the x coordinate of 4. Let's say this is 4. Now there obviously will be two different points, one on this side, let's call that Q1, one value for Q, and the other one on this side, let's call that Q2. They are the same distance, 2 square root of 2, 2 square root of 2, equal distance from that point P. And that is exactly why we are having two different answers to say that, okay, one of the points is 4 comma 5 seconds, that's in the first quadrant, and the other one is 4 comma negative 3 seconds, that lies in the fourth quadrant. These 2 points both are the same distance, 2 square root of 2 away from P. That explains why we have two different answers.